All right, so we're continuing with geometric sequences, and we have this word problem. So 2 managers at a clothing store created a created sequences to show the original price and the markdown prices of an item. Write a recursive formula and an explicit formula for each sequence. What will the price of the item be after the 6th markdown? Now, this 6th markdown actually means the 7th term. Why? Because the first term, a sub 1, is the original price. So then 6 markdowns would be our 7th term. All right, so things we need, a sub 1 and our r, if it is an r. We know if it's an r because we're going to take, say, 51 divided by 60, and I get 0.85, and I'm going to try another one, 43.35 divided by 51, and we get 0.85. And I try the next one and I get 0.85. So my ratio, common ratio, is 0.85. And my a sub 1 is the first term of the sequence, which is 60. Now, from here, my recursive formula, I'm going to do a sub 1 equals 60. And then I'm going to write a sub n equals a sub n minus 1. So the term before times 0.85. And that's our recursive formula. That one's done. Now my explicit, I'm going to have a sub n equals a sub 1, which is 60, times our 0.85. And then we're going to have n minus 1 as our exponent. So that's the explicit formula. Now we've got to plug in to one of these and solve for that 7th term, which would be our 6th markdown. Now, I could plug into this top one, but I'm going to have to simplify that until I get to the 7th term. I'm going to plug into this explicit, and I'm going to do a sub 7 is what we're looking for. We're going to do 60 times 0.85 to the 7 minus 1. So that's going to give us 60 times 0.85 to the 6th power. All right, so 0.85 to the 6th power is 0.377 with our decimal continuing on. And then I'm going to take that times 60, if my phone doesn't just choose to change. And we get that this is approximately $22.63. That would be the 6th markdown for the first sequence. Now, on the second sequence, if I do 52 divided by 60, I get 0.866 repeating. If I do 44 divided by 52, I get 0.84. So we're not the same sequence, or this isn't a common ratio. We're not doing a geometric here. But if I do 52 minus 60, I get -8. And 44 minus 52 gives me -8. So I have what we call a common difference of -8. We still have a first term of 60. Now, way back when we did our equations chapter, our linear equations chapter, we could have done a lesson on arithmetic sequences. We didn't. Because we weren't sure how we would be on time. But basically it's not much different. So our recursive, we're going to do a sub 1 is 60, and then we're going to say that a sub n is going to equal a sub n minus 1 minus 8. So in this case it'd be 60 minus 8, and then we would just keep going. So this is our recursive. Now, when it comes to our explicit, we again start with a sub n. We'll take our difference, so this is a -8, times n minus 1. This is always the same, n minus 1. So this would be our difference. So basically for arithmetic, explicit would be a sub n equals the difference times n minus 1 plus our a sub 1. And that's how it works. So in this case, we put plus 60 And then our equation would be done. And there's our explicit. If we were doing this one, I'd probably have you simplify them. But for what we're doing now, this is all you need. And then we're going to plug in a sub 7. So negative 8 times 7 minus 1 plus 60. And so 7 minus 1 is 6. So we have negative 8 times 6 plus 60. So negative 8 times 6 would be 48. And then we're going to do 60 minus 48, or negative 48 plus 60. And we get that a sub 7 will equal $12. So if we're being honest, as a customer, I am more for employed with the second sequence than I am the first, because after 7 markdowns or 6 markdowns, I'm only having to pay $12, not $22. So, but that's how we do it. We had both a geometric and what we call an arithmetic sequence happening on that one. All right, but how do we graph these? The geometric sequence has an initial value of 6, so I know a sub 1 equals 6, and a common ratio of 2. So r will equal 2. So knowing that, I know that a sub n is going to equal 6 times 2 to the n minus 1. That's my explicit formula. So now I'm going to make myself a table of charts here, or a table of points, as we will. So we have x and y, and I'm going to start at 0, 1, 2, 3, 4 maybe, and then we're going to do 6 times 2 to the 0 minus 1. And I don't think I'm going to like the answer to this just because. So I've got 2 to the negative 1 power, which is 0.5. And then I'm going to take that times 6. So 0, 3. And then I'm going to plug in. So 6 times 2 to the 1 minus 1. So this one's going to be 2 to the 0, which is 1, and 6 times 1 is 6. So we got 1, 6. And then 6 times 2 to the 2 minus 1. So we'd have 2 to the first power, which is 2, times 6 is 12. So we've got 12 here. 6 times 3 to the, or 6 times 3. 6 times 2 to the 3 minus 1. 2 squared is 4. 6 times 4 is 24. Then we're going to have, so we have 24. And if you haven't guessed it, maybe you already have, we have 6 times 2 to the 4 minus 1. So 2 cubed is 8. 8 times 6 is 48. And so we end up with 48. From here, I'm going to count by tens. So this would be 20, 40, 60, 80, and then up here would be 100. So 0, 3, this is 10, so 3 would be about here. 1, 6 would be just above halfway. 2, 12 would be just above the line. 3, 24, so there's 20, so just below halfway. 4, 48, 40 almost to the 50, and then we just draw our curve here, and there's our geometric sequence graphed as a function, because every geometric sequence is a function of an exponential function for our geometric sequences. All right, that is it. Until next time, 8th graders, stay classy. Cartwright out.